The lecture is about fluid mechanics. In this video lecture, we are going to briefly discuss about problems on viscosity. Here we are going to discuss about problems on viscosity with multi-plates where two plates are being fixed. That is, your top plate and bottom plate are fixed. Between these two plates, we are having a moving plate. The distance between your top plate and your moving plate is dy1, and the distance between your bottom plate and your moving plate is dy2. The relative velocity of your moving plate is u. See, in your multiplate problems, we have two conditions. First condition, if dy1 is equal to dy2, always your a1 will be equal to a2 over here. If your dy1 is equal to dy2, then we can say tau1 equal to tau2 and f1 equal to f2, where tau1 is your shear stress in Newton per meter square, F is your force in Newton, and your A is your area in meter square. The second condition for multiplate problem is if dy1 is not equal to dy2, here also your a1 will be always equal to a2, then your tau1 is not equal to tau2, f1 is not equal to f2, where your tau is your shear stress in Newton per meter square, and f is your force in Newton, and a is your area in meter square. See, on this condition, we have to separately find your tau1 and tau2. Okay, whereas on your previous condition, that is your dy1 is equal to dy2, we need to find only tau1. From there we can calculate easily your tau2. Problems on viscosity. In this problem, it is stated that two large plates are 2.4 centimeter apart. The space between the plates is filled with glycerine. What is the force required to drag a very thin plate of surface area zero point 0.5 meter square between the two large plates at a speed of 0.6 meter per second? There are two conditions given over here. First condition, the thin plate is at the middle of two large plates, that is your dy1 is equal to dy2. The second condition, the thin plate is at a distance of 0.8 centimeter from the top. The dynamic viscosity of your oil is 0.81 Newton second per meter square. Given, they have given your area as 0.5 meter square. Therefore, A1 equal to A2 is equal to 0.5 meter square. Then they are given your velocity as 0.6 meter per second. Therefore, your change in velocity, by assuming your initial velocity as 0, your change in velocity du is equal to zero point 0.6 meter per second. The dynamic viscosity is being given as 0.81 Newton second per meter. Solution. See, here we have two fixed plate and one moving plate. The distance between the fixed plate and your moving plate is 1.2 centimeter and 1.2 centimeter. The relative velocity is u. Condition 1, your dy1 is equal to dy2. Since it is on centimeter, to convert into meter, it will be divided by 100. Therefore, 1.2 into 10 to the power minus 2 meter. Shear stress, tau is equal to mu into du by dy. Once again, tau1 is equal to mu into du by dy1. We know the mu value as 0.81 and your du as 0.6 and dy1 as 1.2 into 10 to the power minus 2. Substituting the values, we get your tau1 is equal to 40.5 Newton per meter square. Since dy1 is equal to dy2, then we know that tau1 is equal to tau2. Therefore, tau1 equal to tau2 is equal to 40.5 Newton per meter square. Force tau1 is equal to F1 by A. So I know my tau1 as 40.5 and my area as 0.5. Therefore, F1 is equal to 20.25 Newton. Since dy1 is equal to dy2, therefore F1 is equal to F2. We have already calculated F1 as 20.25. Therefore, F1 equal to F2 is equal to 20.25 Newton. The total force F is equal to F1 plus F2. Substituting your value of your F1 and F2, we get the total force F as 40.5 Newton. Condition number 2. See, they are given the distance of the fixed plate to a moving plate at the top as 0.8 centimeter and the distance between your bottom plate and your moving plate is 1.6 centimeter. Therefore, dy1 is equal to 0.8 into 10 to the power minus 2 meter. dy2 is equal to 1.6 into 10 to the power minus 2 meter. The relative velocity of your moving plate is u. Shear stress tau is equal to mu into du by dy. Therefore, tau1 is equal to mu into du by dy1. Substituting your values over here, your mu as 0.81, your du as zero point 0.6 and your dy1 as zero point 0.8 into 10 to the power minus 2. We get shear stress tau1 is equal to 60.75 Newton per meter square. For dy2 is equal to 1.6 into 10 to the power minus 2 meter. For that, we are going to calculate your shear stress. We know that tau is equal to mu into du by dy. Therefore, tau2 is equal to mu into du by dy2. Substituting the values of mu, du and dy2, we get tau2 is equal to 30.375 Newton per meter square. Comparing the two shear stress value, we can one thing is being observed, that is the distance between the fixed plate and your moving plate is being minimum, then you have your maximum shear stress. If the distance between your moving plate and fixed plate is maximum, then you will be having minimum shear stress. Since dy1 is not equal to dy2, we are going to calculate force for two different conditions. First, tau1 is equal to F1 by A. We know that tau1 as 60.75 and your area A as 0.5. Substituting it, we get your F1 is equal to 30.375 Newton. Your next, tau2 is equal to F2 by A. Tau2 is 30.375 and your A is 0.5. Substituting your values, we get your F2 as 15.1875 Newton. Your last step, total force F is equal to F1 plus F2. Substituting your values of your F1 and F2 over here, we get the total force F is equal to 45.5625 Newton. In the next problem, the space between two parallel plates is 25 mm apart and it is filled with a liquid of viscosity zero point 0.7 Pascal second. A plate of 250 mm into 250 mm at a velocity of 150 mm per second moves between two large plates. The distance between the plate and the moving plate is 6 mm. Assuming there is a linear variation in velocity between the plates, determine the force exerted between the plates. See, we have a word over here, linear variation velocity. Normally, while you are solving your problems in viscosity, our assumption is the velocity varies linearly. Given mu zero point 0.7 Pascal second. Pascal can be written as Newton per meter square. Therefore, mu is equal to zero point 0.7 Newton second per meter square. Next, area. A1 equal to A2 equal to 250 into 10 to the power minus 3 in order to convert your mm into meter divided by 1000, okay, into 250 into 10 to the power minus 3. They are given the velocity. See, they are given only final velocity. We are assuming your initial velocity as 0. Therefore, change in velocity du is equal to 150 mm per second. So converting into meter, we get 150 into 10 to the power minus 3 meter per second. Solution. They have given dy1 is equal to 6 mm, that is 6 into 10 to the power minus 3 meter. See, the distance between the two fixed plate is 25 mm. The distance between the top fixed plate and a moving plate is 6 mm given in the problem. Therefore, the distance between the bottom plate and moving plate will be 25 minus 6. Therefore, it will be equal to 19 mm. Therefore, dy2 is equal to 19 into 10 to the power minus 3 meter. Shear stress. Tau is equal to mu into du by dy. Tau 1 is equal to mu into du by dy1. Substituting the values of mu, du and dy1, we get tau 1 is equal to 17.5 Newton per meter square. Next, for dy2 is equal to 19 into 10 to the power minus 3 meter, we are going to find your shear stress. We know that shear stress tau is equal to mu into du by dy. Therefore, tau 2 is equal to mu into du by dy2. Substituting the value of your mu, du and dy2, we get tau 2 is equal to 5.526 Newton per meter square. Since dy1 is not equal to dy2, therefore, we are going to calculate your force for two different conditions. First, tau 1 is equal to F1 by A. We know that tau 1 is equal to 17.5 Newton per meter square and area A as 0.625. Substituting your values, we get F1 is equal to 1.093 Newton. Then tau 2 is equal to F2 by A. Tau 2 is equal to 5.526 Newton per meter square, which we have already calculated. Substituting a A value, we get F2 is equal to 0.345 Newton. The last step of the problem is to find the total force. We know that total force F is equal to F1 plus F2. We already calculated your F1 value and F2 value. Substituting the value of F1 and F2, we get the total force F is equal to 1.438 Newton.